Let's take a look at how we can use seismograms to determine where an earthquake epicenter is using something called triangulation. Tri means three, so it might not be a surprise that we're going to have 3 seismograms here. So these are the printouts from the same exact earthquake event in 3 different locations, and we're just going to call them location A, B, and C. Nice and easy. And so you may have learned in your text or in one of my other videos that the P and S wave is super important to being able to understand how far away an earthquake is from a given location. So we're going to identify our P waves. They're always the first ones. That's here, P wave, and P wave. The second set that comes rolling in is going to be the S wave, so S, S, and S. It would actually be a third set, our surface waves, but we're not going to deal with that here. All right, so our P and S wave gap is going to relate to how far away the earthquake was. And so let's just say that this is a 5-second gap, and this is going to be a 10-second gap, and this is going to be a 15-second gap. You can see that they get bigger and bigger and bigger as we go down here. And then now we're going to be able to relate this to a distance. So I'm going to totally just round this, but it'll do an okay job. 5 seconds would be 25 miles about, and we're going to use miles to make it easy. 10 seconds would be a 50 mile away, and then our 15 seconds is going to be 75 miles away. And of course, this is a little approximation, but it'll get the job done for what we're trying to show here. All right, so A is closest, B is the next close, and then C is furthest away. So now we need to plot these locations on the map and figure out where A, B, and C is. So let me go ahead and do that. Okay, so now we have this kind of generic map with these 3 locations marked on there. A, which we know is 25 miles away from the epicenter, B, which is 50 miles away, and C, which is 75 miles away. And we've got this little scale bar on the bottom that shows us that from here to here it's 100 miles, and then the other values incremented there accordingly. And so we're going to take location A, and we know that it's 25 miles away from that location. So we would take our little scale bar and we would draw a circle that's about that size away. And of course, we'd be more accurate if we were doing this for real, but this is just for kind of demo purposes. So that's a pretty okay circle-ish. And then we take location B, and so it's going to be 50 miles away. And so we would do a circle that's going to do something like this. So 50 miles away, we're coming in something like this for 50 miles away. So now we know we have 2 possible locations. It's either here or here, because both of those locations are 25 miles away from A and 50 miles away from B. And then we would take our C location, which I've got a little bit off there, but let's take it and it would do something. Our 75 miles would come in something like that on our map there. All right. So it's not perfect, but what you can see, is that basically they're all coming in right in here. So that's where our 3 locations are meeting. So it's 25 miles away from A, 50 from B, and 75 from C. And so it does take 3 locations, because you can see if you only have 2, you end up with 2 possible locations. When you throw that 3rd location in there, it really narrows that down for you. So that's triangulation to find an earthquake's epicenter.